Our first lab is basically about determining the charge that a piece of charged tape carries and determine the excess charge on the U-tape, and learn about how charge is transferred by physical contact. The fundamental physical principles that I use in this experiment is conservation of charge, Coulomb's law, and Newton's second law. Also, I use the formulas that we've learned in this class before. My major results are that the U-tape carries positive charge, and the charge on the U-tape is around 2.333 times 10 to the negative ninth, and the ratio of electrons to the number of atoms on the tape is around 7.2915 times 10 to the negative eighth. When I was doing the calculations, I ignored the air resistance on the U-tape and treated the tape as though it were a point charge. And I also assumed that the U-tape I made had about the same amount of charges, evenly distributed along the length of the tape. To make sure the charge that the U-tape carries, I use it to interact with objects that carry different charges. Since the objects that carry the same sign of charge repel each other, and those that carry the different charges attract each other, I get the result that the charge on the U-tape is positive. Based on my assumptions, the two tapes that repel each other can be seen as two positively charged particles, and there are two forces on the y-axis of the U-tape, which is the electric force from the lower tape and the gravitational force. According to Newton's second law, the two forces are balanced and have the same magnitude because the U-tape is still and the acceleration is 0. In this way, using the formulas that we've learned in this class, we can easily get that mg equals to 1 over 4 pi epsilon times q squared over r squared. And q equals to square root of mg 4 pi epsilon 0 times r squared. In this experiment, the length of my tape is around 0.2 meters, and since the clear tape is around 1 gram per meter, I get the mass of the tape of 0.2 gram, and then get the gravitational force on the U-tape, which is 0.00196 newtons. The distance between my two tapes when one began to float above the other is 0.05 meters. What I did next was plugging in the numbers and get the charge that the U-tape carries. To get the number of atoms on the U-tape, I used the area of the U-tape over the area of a plastic atom, which has a length scale of around 1 times 10 to the negative 10th meters. And to get the number of electrons, I used the total charge divided by the charge of one electron, which is 1.6 times 10 to the negative 19th power. So the ratio of the deficient electrons to the atoms on the U-tape is simply just the number of electrons over the number of atoms. For the coding part, basically I used the two white spheres to represent the two positively charged particles, and then the green arrow represent the electric force and the blue arrow represent the gravitational force on the U-tape. Then I used the code as shown in the slides to get the final answer. There are two additional questions to answer here. The first one is, what if electrons have positive charge and protons have negative charge? I think the charge of the tape would change, but the phenomenon in this experiment won't change. And the objects that carry the same sign of charges will still repel each other, and those that carry the same sign of charge will still attract each other. The second question is that why is it important to handle the charged tape as little as possible? I think it's because if we hold the tapes for too long, the electrons in our hand may transfer to the tape and thus impact the charges that are originally on the tape. In this lab, I learned how electrons can be transferred from an object to another through physical contact, and how to apply the physical principles and the formulas that we've learned before to real-life problems. If I have more time, I would like to do the optional part in the lab instructions and see if I can make two U-tapes that carries different charges.